All right, good morning. So we're going to review limits. And we will start with Josh. So I'm going to rewrite this because I don't like the way this looks, Josh. You don't have to write it this way, but I'm going to. Josh, do you know the limit of that?
8.
What?
8.
8. How'd you get 8? Perfect. That's exactly correct. Okay. Now, you may not know this answer because I may have failed to tell you this, okay? But I'm not exactly sure. Why can you substitute 2 into that function? I think you're right, but I'm going to get hearing aids. I'm pretty sure. Okay. I might even lie and just tell them I can't hear anything at all. But then they'd be asking me a question, I'd be lying. So then, wouldn't that mean I would hear? So I'm at a fork in the road. Okay. So you're gonna have to say to me again what you said. I agree 100%. Okay. I agree 100%. Now, if there was a hole there, I could get the same type of answer, correct? Right? But if there was a hole there, there's no way I could put 2 in there, correct? So I know there's no hole, which means it's continuous, correct? How do I know by looking at that function that it's continuous? Do I know what type of function it is? Yeah, what type of function is it? It's a parabola. That's what makes a parabola. That works really good. Okay, it's a quadratic equation, and it falls under the group of polynomials, and they're always continuous. Correct. So that means I can not have to worry about a hole. I could just plug it in and know that's what it's approaching. So you defined it perfectly, but I think I failed to tell you that I know anytime it's continuous that my shortcut is just plug the number in, and I know what it's approaching. Okay. All right. Over here, Cameron, when I put a -2 in here, I get 4 minus 4 over a -2 plus 2. And that's not good, okay, because that gives me 0 over 0, and that's kind of like Voldemort. We're not even supposed to say it in front of the class, okay, because the person that will not be named or whatever it is. So what do you do here instead?
You could factor out the x squared minus 4 to x plus 2 and x minus 2.
Can I ask you how x plus 2 and x minus 2 are related? Do you know what their names are called?
They're both linear, so they would make it fun.
Yeah, but how are these related?
They're conjugates.
They're conjugates. One's Bill, one's Bruce, right?
Okay. You can factor out the x plus 2 and you just get x minus 2.
So those simplify, right? Now, is this x minus 2 the same as this? No. They're almost identical, correct? But this is continuous because it's a polynomial, right, Josh? It's a linear equation. It's a polynomial. This is not. Because this is no -2. Okay? So they're exactly the same, except what does this have in it? A hole at x equals -2. So what is my limit right here? What is it approaching?
-4.
-4. All right. Emma, do you have any idea how to do this one? Okay. So I got the limit as x approaches 0, and I got x minus 1 over x. So what do you want me to do? Oh, that's not right, by the way. I wrote it wrong. There I go. Sorry. So what conjugate do you want to use? Like this? Okay. So I get the limit as x approaches 0. Down here I'll have x times parentheses square root of x plus 1. what will I have on top? X minus 1. Because multiplying by conjugates means there's no inner and outer, right? That's sum of 0. All right, you know what word I use right here? Right now, when I plug in 0, I get 1 over 0, right? You know what word I use? Poop. Yeah. You know why? Yeah, because it does not exist, right? So the answer is does not exist. But do I know what it's doing here? Can I approach 0? Can I approach 0 from the left? I bet you I can't. Because I can't put a negative in here. Right? I couldn't put a negative into here either, could I? Right? So I can only approach it from the right. So what numbers would I plug in here to approach from the right? Like positive what? 0.1, okay. So I'm going to go to the machine. And I'm going to put in parentheses square root of x minus 1 parenthesis divided by x. Is that correct? And you want me to go to a table. And you want me to type in 0.1? Does that tell you anything? What do you think the answer is? Can you tell now? I think it's a negative 6.87. Excuse me, a negative 6.837. So what do you think? Is he approaches that number? You think it's a negative 6? Okay. .01? You know what number that is? Yeah. Is that enough for you to know? Okay. Negative infinity. Is that what you said?
Yeah.
Well, you're right. It does not exist. Holland, can you see this?
Yep.
Okay, what do you think? Let's go. Should we go to the machine? You don't even have a guess? What?
No, I don't.
Can we approach it from the right and left?
Yeah.
Okay. So what numbers you want put in there?
0.1.
That enough? That enough?
Okay, now negative.
You really want me to put negative in there? No, I will.
Well, that one's approaching.
Correct. You think negative will be the same way? Okay, you want me to put a negative in there? Negative point what?
9.
9? I'm headed towards 0.
Or negative 0.0.
Am I making you nervous? We'll give it negative point 0 what?
1.
They're the same. Should they be the same?
I guess.
Well, you're not sure.
I'm not
What am I doing to them?
sure.
What happens when you square a number?
Oh, it
Okay. So what do you think your answer is? Okay. Right? All right. So these 4 problems, the reason I bring them up, you are headed to a particular number, correct? Right? This, when we take our limit and go to infinity, whether it's negative infinity or positive infinity, we are looking at what is happening at the way, 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 way down the road. Okay? We are examining where our y's are going as our x's increase. Or decrease, I suppose we could say. Because when you go to the left, you decrease, right? So here's an example, right? Maya, do you notice the last 2 examples I used a graph? Well, I didn't use a graph, but I used a table, right? So we're going to look at this, and we're going to use a graph and a table. But those are on the next page. Can I move on to the next page? So here's this one again. I'm taking the limit of this. And I'm going to write plus or minus. And it's 3x squared over x squared plus 12. Okay? So if I take a look at that, I don't care about this. Don't care. Why? Because those are itty-bitty numbers. They're close to 0. I care about what's happening way out here and beyond. Here, different stuff is happening, right? Here you can say, hey, you got an absolute minimum, Mr. Kruger. It's concave down, concave down. But is this increasing without bound? Is it keep getting bigger and bigger? Maya, it looks like there's a ceiling on top. Would you agree? What would that ceiling be? What? What do you think the name of that asymptote is? Well, it's horizontal, right? So rather than y equals, it's, excuse me, instead of x equals, it's y equals. I screwed you up, sorry. Y equals what? Why, what else would it be? Right? Doesn't it seem like it's getting closer and closer to 3 all the time? Now, here's a table. So notice I write down the limit as x approaches infinity, whether it's left or right, looks like it's approaching 3. And here I plugged it in a table. And I don't care what's happening at negative 1 and 1, because it's not even pretty close to 3. But as I get to a negative 10, as I get to a negative 100, it's getting closer and closer to 3. Would you agree? This right here is called a horizontal asymptote. And Morgan, you know how they're found? If you go hunting for horizontal asymptotes, you know how you find them? As soon as you say x approaches, which is the correct terminology, we're talking about what thing? Limits, correct? Would everybody agree? Now, here's what you have to keep in mind. Do I find vertical asymptotes, the one that goes like this, up and down, do I find them the same way? I don't, do I? how do I find vertical asymptotes? It's what makes the what? Denominator what? 0, right? It's a different way, correct? Why? Because I'm finding a different thing. To find horizontal, I take limits. To find vertical, I examine the denominator. Now, can that ever be equal to 0? Well, for that to be equal to 0, that means this would have to be a negative 12. Would you agree? Can that be a negative 12, Josh? No, it's impossible. Why? What does this mean? It's always what? Positive, right? It can never be negative. Next page. Alrighty. So the third method is by doing algebra or doing something analytical, and these are the two most important limits. Okay? So Allie, I'm taking the limit. X is getting extremely big. Now, what's your definition of extremely? Okay? My wife thinks I'm getting extremely big. Okay? So let's put in 230 and cube it. So if I have 2 over 230 cubed, what happens to my fraction? 2 divided by 230 cubed. Is that a big number or a little number? 2 divided by 230 cubed. This gets smaller,
Yeah.
right? That fraction gets smaller. Now let's make it 1,000. 2 divided by 1,000 cubed. Did it get smaller? Okay. Does it become negative? Okay, what about 2 over 1,000,000,000 cubed? Did it get smaller? Did it become negative? Where am I headed? Well, you said it got smaller, and infinity is not small. It's going to 0. So Abby, let's go the other direction. Let's take 2 divided by a negative 500 cubed. Pretty small, right? Take 2 divided by a negative 1,000 cubed. Smaller? Yeah, kind of. It's getting closer to what? Is it? This whole thing. Two over 1 is 2, correct? 2 over a negative 1 is a negative 2. 2 over a negative 10. What's that? Or how about a negative 0.2? Can I say that? You're right. I just want the decimal. What about 2 over a negative 100? What about 2 over a negative 1, 2, 3, 4, 5, 6? A lot of zeros, right? Is it getting bigger? Is it going to infinity? Where's it going? I made it negative 2 and made it negative 0.2 and made it negative 0.02. You're going to say negative 0.000 something with a 2 at the end, right? It's approaching 0 also. So in other words, and I'm going to put a C here instead of a 3. If C is a constant and R is a positive rational number, the limit of this, as you go to positive or negative infinity, and this thing keeps getting bigger, the denominator keeps getting bigger. The denominator keeps getting bigger and bigger and bigger, and the numerator never changes. I'm headed to what? 0. That's a huge idea. because now I have this. And I could take and break this into two limits. I can take the limit as x goes to infinity of 4 minus the limit as x goes to infinity of 4 over x, 7 over x squared. 4 is always 4. Would you agree with that, Kyle? Okay? If I give you $4 today, okay, and the days increase and I keep getting older and older, and pretty soon I'm 97, and you'll say you'll be at some high school reunion and Cora will be there, and you say, yeah, remember when Kruger gave me $4? My age has increased, hasn't it? But did I still give you that $4? Did it change that $4? I knew you were going to give me the inflation thing because you've been listening to Mr. Bauer. Are you in economics? No, but you already probably got an A in economics just because you said that. Okay? Okay. But I don't give you your grade. But that, how this changes does not affect 4, does it? Does it affect this? Does it affect this, Kyle, as x gets bigger? What I'm pointing at. Can you see what I'm pointing at? As x gets bigger, does that fraction change? It won't affect the 4. Does it affect that? What does it make this go to? 0, right? So I'm going to have 4 minus 0. What is 4 minus 0? 4. So that limit is 4, isn't it? So if something's in this form, it's pretty easy to figure out the limit. Wouldn't you agree? It's just this constant, because that's going to 0. So what I'm going to do is I'm going to manipulate algebraically to get this to look like that and to get this to look like that. How am I going to do that? I'm going to look at this, and I'm going to look at the exponent. There's an exponent of 1 here. So I'm going to take the limit as x goes to infinity. I'm going to put 2x plus 5. I'm going to put parentheses around it, and I'm going to multiply it by 1 over x. And down here, I'm going to have 3x plus 1. And I'm going to put parentheses around it, and I'm going to multiply it by 1 over x. Where did I get 1 over x? I'm going to show you in 1 second. I got the x from here. 1 over x is 1, right? 1/10 over 1/10 is 1. So now, why did I choose that? Because I want it in this form. And it's going to become the limit as x goes to infinity. If I distribute that, don't I get 2 plus 5 over x? On the bottom, don't I get 3 plus 1 over x? Do you see that, Cameron? Doesn't this kind of look like that? Don't I have a constant plus or minus something that I know is going to go? Where is this going to go? To 0. Where is this going to go? To 0. Is it affecting the 2? Is it affecting the 3? No. So I got a constant plus or minus something, and that plus or minus something is going to 0, right? So what do I have left as an answer? 2/3. Well, let's go to the machine. Because the machine knows everything. Parentheses, 2x plus 5. Oops. Divided by parentheses, 3x plus 1. Look at that. Doesn't it look like it's starting to flatten out right here? Doesn't it look like it's starting to flatten out right here? If I change my window, you see that starting to flatten out as I go further? In fact, I'm going to put in 2 divided by 3 right there, and I'm going to draw that. I don't care what's happening here. Does everybody understand that? I only care what's happening out here. There's a horizontal asymptote at y equals 2/3. Everybody with me on that? I know you're getting tired. Okay? Did you split wood this weekend? Yeah. I split wood and stacked it for 12 hours this weekend. Look at me. I don't even look like I could swing an axe. I look more like the stump that I cut. You ever consider that? How is that physically possible? I should have called Hunter. All right, now I'm going to get this one in the exact same form. Okay? How much time do I have here? 5 minutes? 10. I'm going to give myself 5 minutes. Okay? So this, you see how this has an x squared? I'm going to multiply. I'm going to take the limit as x approaches infinity, and I'm going to take 2x plus 5, and I'm going to multiply by 1 over x squared. So it's the denominator that where I choose to multiply by. So if this was x, I would choose x. If it was x cubed, I would choose 1 over x cubed. So this is going to give me the limit as x approaches infinity. Well, this is going to be 2x over x squared, right? 2x over x squared. That's 2 over x. And this is going to give me 5 over x squared. This is going to give me 3 plus 1 over x squared. Now, it's a complicated form, but I know where this is headed towards. I know what this is headed towards. I know what this is headed towards. And I know this doesn't affect anything, does it? You have a comment, an answer, or both. Okay? What are you going to give me first? Okay? It's always 0. So how'd you get 0 from here? This approaches 0, this approaches 0, this approaches 0. So are you telling me there's a shortcut? Are you telling me the shortcut is dependent upon the degree? So are you telling me that if the degree was greater in the bottom than the top, your answer would be 0? What would be your horizontal asymptote then? Okay, you got to give me an equation. What's another name for y equals 0? The x-axis. Does everybody hear them? So the x-axis in this case is the horizontal asymptote. Here, what about this? Let's keep going with this. Here, they're the same, aren't they? Could I have just looked at that and known what it is? What would you get? What are you looking at? What are these called? They're a specific type of coefficient. Do you remember? What? Leading, is that what you were going to say? It is really cool how you're able, with your mind, to get her to speak the right answer and at the same time say not quite the right answer. That is quite remarkable. The leading coefficient. Do you remember in algebra when they said, hey, when you write a polynomial, you have to write it in order dependent upon the exponents? And they don't tell you why. They tell you its proper form. Well, this is the reason why, because it tells you information about functions. That's why it's important. So if on the next quiz I give you this, oh, you can't see this. Can you see it now? I don't know. You can't read my handwriting?
I'm trying to decide if that's a 1/9 or 119.
It's 119. That's a 70. What else can't you read here? What's the answer? Right? Because 10 is a what, Kyle? 2 is a what? What is 10 divided by 2? What's the degree of this polynomial? What's the degree of this polynomial? The rest of this stuff doesn't even matter. You just have to look at this stuff, right? Would everybody agree? Agree? All right, now. We'll see if she notices. Okay.
Hello, this today from.
You know what my middle initial is?
Victor.
Van. How much time do I have, Josh? Huh? 20 minutes? Hunter, what's the answer to this? Okay, got easy, didn't it? What about this one? It does. It's y equals 2/3 x. It's an oblique asymptote. You know why it's oblique? Well, horizontal one, what? Diagonal line, okay? Now, do you know how I figured it out? By how much? By 1, okay? So that means you're going to have a line, okay? And you got to look to make sure that this degree is one more than that degree, okay? So it automatically creates a line. You know how I determine the line? Yeah, by this. You know what this is called? Long division. Never liked it? Are you an anti-long division person? Okay, can I ask you why? Because it took a long time, right? Yeah, we're going to do a little bit of long division. I don't think it'll be that long.
The other one
Okay.
is better.
Okay?
Like, what's the other one called? Isn't it like
Synthetic division?
synthetic
Yeah, you
division?
can, but synthetic division only works when you're dividing by a linear equation.
You could do it with a square. It just takes